Imagine that you just joined a new company as DevOps engineer, and this is a startup company. They haven't had any kind of DevOps department or DevOps processes implemented so far. So basically you are responsible to implement every processes related to DevOps in this company. In the first meeting with developers, they informed you they have already created their first version of application. They are ready and eager to present it. There are some complaints about a slow process of building images and testing everything locally. So in this case, what set of actions should you do? Hey guys, it's Rafi here, and in this video we're gonna cover all the required steps, including how to think about the problem, how to design the system, and how to implement it. So stay with me. The first step is always know the system. You should be familiar with the system well enough to find an opportunity to improve something or replace something with something else. Let's see what do we have in our case. The current system is very legacy one. We have developers who are developing the codes and then just send the codes to Git Repository. Based on the codes, they build their codes. After building the codes, they create an image that is able to run the code, and based on the created image, they will run a Docker container. So they can just bring up the application in their local host and test it. This is the process here. What is the main drawback of this process? It is all manual. We don't want such a thing. We will try to automate everything as much as possible. So, what design should be replaced with this system? Let's see. Based on the scenario we already discussed about, Git repository could be a good component to start everything. So, in our scenario, in the suggested scenario, developers will put their codes to Git repository, and any events in the Git repository, it could be pushed, it could be merged or whatever, can trigger a pipeline. This is where CICD pipeline came into play. So inside our CICD pipeline are the manual jobs in the legacy system, including building the code, including creating the image, and running the container should be happen one after another as steps. What's the final result and what's the benefit in this? Developers will be free. Developers are no longer responsible to build the codes, build the image, run the Docker container, and test the code. This is not the responsibility of developers after all. This is the first benefit. Developers have more time to focus on their developing, to focus on their code quality. Also, everything would be automated. You can have logs for building codes all in central places, for creating image, for running Docker container, and for the application logs itself. So this is the design that we are going to implement to solve the problem, to solve the first problem of developers. The next important thing is how do we want to deal with these CI/CD pipelines? As a matter of infrastructure, which infrastructure do we want to install this CI/CD or set up this CI/CD against? We should consider several things. For one thing, there is definitely more than one CI/CD pipelines, right? So just imagine the situation that there are several developers are working on different microservices. For each push or each commit or each merge, there should be a CI/CD pipeline. Developers should not wait for each other, right? There should be an ability to just start building everything simultaneously till the specific limit, for sure. This is very important to think about the scalability of this CI/CD system, right? So choosing the infrastructure plays a critical role here. What is our choice? We want to set up the CI/CD pipeline inside the Kubernetes cluster. Why? Because Kubernetes is a very powerful orchestrator, container orchestrator, and it just provides us with more flexibility related to scalability, because we don't need to be worried about the scalability issues anymore. Kubernetes has its own horizontal pod scaling, so it can just scale up the runners or scale it down, so it can also provide some saving as a matter of cost, because only the resources that are needed are in use, and we don't waste any resources here, but we can save money. So our solution is based on Kubernetes, and we're gonna implement our CI/CD system inside a Kubernetes cluster. The other interesting topic that we should think about is that how do we want to implement our infrastructure? Obviously, because we are going to use Google Cloud, we have two options here. The first option is to do Google Cloud Console or do everything manually, which is not a good solution. It's absolutely good for learning, but not for implement anything in the production system. And the other option is use infrastructure as a code. There are several tools out there as well for providing infrastructure as a code, but the one that we are going to use is Terraform. Terraform is a very powerful infrastructure as a code tool. So what is our desired design for this part? We are going to use Terraform as a tool for our infrastructure as a code. All the codes related to Terraform should be kept inside Git Repository, so we can track the code. Also, we should know a little bit more about the Google Cloud structure. Inside Google Cloud, you have an organization. If you are using a business account, then you will have an organization here. Inside each organization, you can define several projects. One of the projects for us is DevOps tools, which we are going to implement the Kubernetes cluster for our CI/CD inside it. So this is the general architecture of Google Cloud. We will describe it a little bit more later. But for now, the thing that we should know is that all the Terraform codes are synced with the Git repository. After running Terraform initiate the communication with Google Cloud and instructed what do we want, how do we want it, and at the end update the state of the infrastructure. And before each running, Terraform again just fetch the state to see if the state is according to the code. Without any further discussion, let's see how we can implement such a structure. The first step is to go to Google Cloud Console. Inside Google Cloud Console, you should create a new project. We call this project as DevOps Tools. It's supposed to just maintain all the tools related to DevOps. As you can see, I don't have any organization here because I am using my personal account, so I don't have any organization. But if you are using the company's account, you should have an organization, and below the organization there are several projects and folders and the resources. So for now, just setting the project name as DevOps Tools would be fine. We should wait for a few seconds. Okay, now that we have the project created, let's switch to just created project. Okay, this is a blank project, nothing is there. None of the APIs, Google APIs is enabled here, no resources is defined here, just newly created. So the next step is to map everything we want inside this project relating to Kubernetes cluster or other resources that we want to have inside this project to Terraform. So for this purpose, the first step again is to create a Git repository for it. I already created one. This is a blank repository just created for the purpose of maintaining the codes, all infra codes in Terraform. What I need to do is just make a clone of this and then go to it and open it in VS Code. Now it's time to think about what is the structure of this Git repository. What should be the structure of this repository? Inside this Git repository, I am going to put every code related to all the infrastructure tools, all the CI/CD tools, or whatever DevOps needs during the daily job. So I will create a directory namely infra, and inside infra, this is infrastructure related to CI/CD. We might have other clusters for other purposes, so it makes sense to just structure it like this. So inside it we have a CI/CD, and inside CI/CD what we need to do first to initiate the Terraform is a file to indicate Terraform which providers are we going to use. So let's create a file namely provider. Inside the provider, the code we're gonna have is like this. Obviously, we are going to use Google provider. If you don't know about the Terraform providers, it's always good to have a look inside Terraform resources and Terraform documentation. You can find all the relevant information about different providers, all the options, all the arguments you can set, and everything is there. So when we are using a Google provider, the first thing we need to address is which project this Terraform should use, right? You remember that we created the project. Okay, as you can see, this is the project name, DevOps Tools, and this is the project ID, which is unique, right? So project ID is an ID unique and mapped to your defined project. This is the item we need to use. Here, and then we should decide on which region we are going to use. For this test purpose, I think Europe West works best. In the Terraform section, we should define a backend for Terraform state file. It's very important to have Terraform state file somewhere remote. You should not keep the Terraform state file locally, because in case that this file corrupted or deleted, or you missed this file, all the history, all the state of your infrastructure will be lost, and it's a mess. Always keep it in a safe place, and the best place to keep it is a remote place. We are using Google Cloud, so a bucket would work best for us. So we define a backend for Terraform, which is inside the Google, and the bucket name should be unique. Let's define something unique like daily DevOps dilemmas here, and a prefix for the bucket. So we want it to be inside the Terraform and inside the state directory. The other thing that we want to mention is the version of the provider that we are going to use. It's also an important thing, because as time goes, you would want to just use another version, because from time to time some features will be added. This is the reason we define the version here. Okay, what should we do next? Just think about it. We are going to implement Kubernetes cluster inside Google. What is the first thing we need? The first thing we need is a network, right? Because all the components should be able to communicate with each other. Let's first create a VPC. For creating a VPC, I'm gonna create a Terraform file, namely VPC Terraform. And this is a code for creating new VPC, because most of the time you don't want to go with default VPCs, right? We want it to be configured based on our own usage. So as you can see, in these two blocks, we struct Terraform to enable APIs for compute and container. Compute is the API for creating the compute engines, and container will be used for creating the cluster, the Kubernetes cluster. We should have these two APIs enabled, or we're gonna face with error, right? Because Terraform cannot send some API request to the Google endpoint and just instruct it to create something. The next thing is that we are using a resource, namely Google Compute Network. We define a name for it. Let's keep it as main. When you create new project, there is already a default VPC, namely default, right? But we don't want to go with it. We want to create one. The name of the VPC is set to main. It is original, and also we instruct Terraform to wait for these two services to be enabled, API services that we defined up here. So far using this code, Terraform will create a new VPC, namely main, right? What else components do we need? Obviously, we're gonna need subnets, because we want to just make some isolation inside this project and inside this VPC, right? So what we need to do is first create a file, namely subnet Terraform. Okay, that's what Terraform suits best. And then let's see, what do we have here? This file actually are going to use a resource, namely Google Compute Subnetworks, right? We named our subnetworks as private. We define its range, we define its region. We also assign this subnetworks to main network. This main is the name of the network we already created in the VPC. If you look at the VPC, the name of the network is already defined as main, and this main just refers to that one, so main.id. Is the private IP Google's access? Yes, we don't want it to be accessible from outside of Google. We have defined here the secondary IP range. The secondary IP range is for Kubernetes services and Kubernetes pods, right? So we define two range names, one of them for Kubernetes pod range and another for Kubernetes service range. In order to route the traffic, we also need another component, a router component, right? So let's create it. For creating the router, the only thing we should do is just create another file, namely router.terraform, and then the code would be like this. As you can see, it will use the Google Compute router resource, and we named this router as router. It should be in the same region for the VPC, and as you can see, it's already referred to the main network which defined in VPC file. That's all for the router configuration for now. Now that we have router defined in our network, we also need NAT. Why? Because we need to provide access to the internet, right, from inside our cluster, from inside our VPC, right? So we need a NAT. So for creating a NAT, as usual, create a NAT.terraform, and if we go through the codes, it will use the resource named Google Compute Router NAT. We name this resource as NAT. It should be in the same region again, and it refers to the router we just created, right? We just created a router with the name router, right? And this NAT will be attached to that router. We also define which subnetworks should use this NAT. As you can see, we refer to the private subnet we just created in the subnet file. And what else? It depends on the project service compute. Okay, so we already created all the network resources we need to set up a Kubernetes cluster inside Google Cloud, right? So it's time to create the cluster itself. For creating the Kubernetes cluster, just as the other resources, we create a file, namely kubernetes.terraform, tf, and inside this file, let's see what do we have here. Okay, we created a resource using Google Container Cluster. We named it as primary, right? The location should be in the same region you just defined. We use Europe West 1-D for the location of the master node. Remove default node pools, true. Okay, here is the story. A Kubernetes cluster cannot create it without any node pool, right? So before creation of the Kubernetes cluster, Google Cloud itself create node pools for us, namely default. We don't want these node pools because we don't have any control in the specification of this node pool. So what we do is to instruct Terraform to delete this default node pool immediately after Kubernetes cluster creation. So we set this as true, and initial node count doesn't matter for us because we are going to delete this default node pools. So I just set it as 1. The other two important parts that we should address is the subnetwork and network, right? We already created the network, so we just refer to the network we created, and also subnetwork. We defined a range for the subnetwork private, so we create a reference here. Log service is always useful to set because most of the time we need to look at the Kubernetes logs, specifically if something is happening that we don't have any clue why and when and something like this. So we need this service to dig into the logs and see what's happening under hood. So keep it enabled. The network is a VPC native. I also set another master location because I want my cluster to be a zonal cluster. We set the release channel as regular so that Google itself can take care of update of Kubernetes master nodes and the node pools in Kubernetes version. And for our IP allocation policy, as you can remember, we defined 2 IP ranges, right? Let's see. We defined 2 IP ranges here. One of them is for pod range and another is for service range, right? We have to provide the address of these 2 subnetworks to the Kubernetes. So we just set it here. And also private cluster config. We also set the master IP range, which is here. We also set a CIDR for master nodes here. And for now, we just disable the horizontal pod auto scaling. By running this set of Terraform codes, for now, a Kubernetes cluster will be up. But it's not functional. Why? Because we just instruct Terraform to delete its own node pool, right? So basically, the Kubernetes cluster will have a set of master nodes. It won't have any worker node. So to create a worker node, we are going to create another Terraform files, namely nodepools.terraform. Inside the nodepools.terraform, we will define the specification of the workers we need to use, right? So let's see. The first thing we're gonna need is a service account for Kubernetes, right? Because we want all the pods inside the nodes of the node pools be able to communicate with other components, right? For example, to be authorized to start calling the Kubernetes API. So we first define the Kubernetes service account here, and then we are going to use resource Google Container Node Pool and name it as workers because they are workers. And now it's time to refer it to the Kubernetes cluster, right? We created the Kubernetes cluster and named it as primary, so we just create a reference here. So after this node pool will be assigned to Kubernetes to create a Kubernetes cluster. We want auto scaling enabled in this node pool, so the minimum node count is 0 because in case that we don't have any traffic, we don't want to waste on resources, we don't want to waste money, and set the maximum to 10 for now. Basically, based on the workloads you're gonna have, you have to adjust these amounts, the minimum and the maximum, but for our use case, for now, maximum of 10 is enough. In the node config, we have to define what machine types do we want to available in this node pool. Also, we need to set the service account we just created here to the nodes inside the node pools with this reference. As OAuth scope, we actually allow all the components, all the pods, all the containers inside these nodes and to be able to communicate to all Google Cloud resources, right? So when we set authentication scope as a cloud platform, basically we instruct Terraform to set the configuration for these node pools to be able to communicate to all Google Cloud components. It seems we have all the things that we need. Okay, just adding this to the local Git for now. The next step that we should take is to initiate the Terraform itself. So let's initiate the Terraform using Terraform init. Okay. The reason is that we just instruct Terraform to be connected to the Google bucket and use a specific Google bucket for Terraform state file. But we didn't create that bucket, and that's the reason this error appeared in the command line. Bucket does not exist, obviously. Let's create the bucket first. For creating the bucket, we should go to storage or simply just search buckets. Okay. We need to create new bucket, and it will ask for a name for this bucket. We should choose the name of bucket that we already defined in Terraform code, which is this. Okay, and for choosing the location of the data, let's set it as a multi-region. It should be the storage class. We use this file quite often, so let's just leave it as a standard because we are using it frequently. Nearline, cold line, and archive for another purposes. We need to use standard. Data we will use for sure object versioning, right? So in any case that this file is deleted for any reason, we don't lose the backup, we don't lose the previous version at all. So let's create it first. Okay, now that we have the bucket created, let's initialize the Terraform again. Okay, as you can see, it passed the stage related to just connecting to the bucket, and yeah, we are good to go. Let's say Terraform plan. These are all the components that will be created based on the configuration we just set. As you can see, these are related to creating the node pools, creating the VPC, creating the subnets, and NAT and router. That's true. And the network itself. Yeah, it's the exact same thing that we need. Before applying this Terraform code and just let it to create all the resources we just defined inside the Google Cloud, we first need to authenticate the system that Terraform is running on to Google Cloud, to access the Google Cloud, right? So using auth login, okay, as you can see, it will create a new link for us. Let's use this link, and let's use this link in the same browser that Google Cloud is running on. Okay. Now the machine is already authenticated against the created project, and based on the Google account, let's see what do we have in the VS Code. As you can see, it says that you already logged in as the email address, and the current project something like this, which is not desired for us. And it also says you can use this thing to set the project ID, right? So let's do it. Yes. Okay, good. Now that the system that Terraform is running on is authenticated against the Google Cloud, we are ready to apply the Terraform code and let it take care of creation all the resources we defined in the code. Terraform apply. We just checked all the changes in Terraform plan, so we are quite sure that this is the changes we want. So let's say yes. Okay, as you can see, it is creating resources based on our code. It takes around 20 to 30 minutes. When Terraform creates all the resources we just defined, let's see what do we have in our infrastructure right now. By going back to Google Cloud Console, let's see what VPC do we have right now. Okay, as you can see, that the VPC we defined, which is main, is already created. It's okay. Then let's go to Kubernetes engine, and inside the Kubernetes engine there is a cluster already. As you can see, the name is primary. We want to check the node pools as well. So going to nodes, you can see the node pool we just defined as a worker is here. Minimum 0, which is okay for us. The auto scaling is set to minimum 0 and 10. Everything works fine. This is the cluster that we want to have, and we have it implemented in our infrastructure. For connecting to Kubernetes cluster, all we have to do is just by going to Google Cloud Console, going to Google Kubernetes engine, and then click to connect, and just copy this command and paste it to the VS Code terminal. Okay, and then using kubectl get nodes, we can see the nodes. Yeah, there it is. So we have our cluster already implemented in our infrastructure. Now that we know that the changes we already applied to Terraform code is working correctly, and we have our desired infrastructure set up in the Google Cloud, it's time to push the changes to Git Repository. Before that, please just notice there are some files and directories that we don't want to have in a remote Git repository. For this purpose, I just create a git ignore file with the name of the file and with the name of the directory and the file, just to prevent it to be also available inside Git repository. Let's see what do we have here. Okay. And then yeah, looks good. These are the files that we needed. Git remote repository, right? So going back to the root directory, and then let's say looks good, and then git push origin and master. And now you should see all the changes, all the Terraform codes in your Git repository as well. Let's go back to here, and then yeah, we have infra, and we have all the codes here as well. Looks good. Okay guys, the time of this video has already exceeded 30 minutes, and I don't want to make it any longer. Deployment of Jenkins in this Creating CICD cluster will be covered in upcoming second part of this video. If you found this video useful, please don't forget to hit the like button and also subscribe the channel so that you can get notified on upcoming tutorial arrivals. Thanks again for watching this video, and ciao!